there are other factors that affect sleep. Remember, the word endogenous has N in it, so these are referring to sleep factors inside a person, as opposed to exogenous, EXO, those are external factors. Now, our genetics are the blueprints for how we make proteins and control biological functions in our body. And one of the things that can influence our sleep is when we're ill. So cytokines, also things called interleukins. These are chemical signals that the immune system releases, and those influence sleep. Now, way back when sleep research was started, they were looking for a substance that they were hoping would build up in the brain and result in sleep. And it looks like adenosine is our best bet at that substance right now. Hypnogenic, in other words, signaling or creating a hypno or sleep state. Now, one of the reasons that we believe that sleep is biologically controlled through genetics is that you can actually select for it. So we selectively breed dogs and other animals for certain traits. So that means a dog's size, its behavior, so you probably are familiar with the differences between, say, a lab and a chihuahua. A chihuahua was bred to go after burrowing animals and be quite vicious for small animals, versus a lab, which isn't bred for those things. And so behavior, other traits, physical traits can clearly be selected for. So if you can breed for it, it means in some way that particular thing is controlled to a certain degree by genetics. Not all the way, not 100% necessarily, but to a certain degree. And in fact, using flies, we can basically measure how long flies stay quiescent. In other words, how long they sit and don't move versus how long they fly around. And we can do that using these kinds of tubes. We then have the animals stay at certain levels based on how quiescent they are. And then we can selectively breed flies that like to essentially stay quiet for longer periods of time. And then we can selectively breed together short sleeping flies. And in fact, we can select for this trait of long versus short sleeping. And this is an example of kind of the U-shaped or normal distribution you would see for any trait in a population. This particular trait is sleep duration and the number of individuals. So you've got individuals on the extreme who are short sleeping, individuals on the other extreme who are long sleeping, and everyone else kind of falls in the middle. In fact, the vast majority fall in the middle. But if we select for these extremes, what we end up with are two different selected populations. So once again, this suggests that whether you're a long or short sleeper may in some way be influenced by genetics. And remember that genetics also refers to the genetics of your grandparents. And so if you're not exactly alike in your sleep habits to your biological parents, remember that that may be because of the influence of the genes contributed by your grandparents. So we also, as I said, we were talking about illness. So health and illness can definitely affect sleep time. So it looks like infections increase non-REM sleep cycles, particularly the deep part, the slow wave part of sleep, and the amount of delta waves. And in fact, it causes problems with REM sleep and sleep maintenance. And this may be because of signals carried by these cytokines and interleukins. Once again, these are very similar to neurotransmitters, except these compounds are released by the immune system and immune cells, and they can travel further in your brain and in your body. So why would it be that we sleep more when we're ill or when we have an infection? Well, it might allow our body to allocate more resources to healing or to producing a fever. And the reason we might produce fevers is because some viruses and bacteria don't do well under high temperatures. We do know that sleep deprivation causes changes in the immune system that can actually be decremental. In other words, The more sleep deprivation you have, the worse it looks like your immune system can fight off viruses, and the effectiveness of flu vaccines may actually be decreased. There's a lot of research to suggest, for example, that medical students during exam times, which are times not only of stress but of sleep deprivation, showed changes in things like cold sores, and that would be controlled by herpes virus simplex 1, which about, I think, 80% of Americans have. We do know that stress can affect sleep, once again, likely due to cortisol, the hormone we've already discussed. And cortisol also decreases most immune system activity. So recovery from acute stress usually includes increases in both non-REM and REM sleep. Now, we talked about endogenous factors. Well, there's things you can do, sleep hygiene, that will actually help both process C, which is about circadian rhythm control, and process S, which is about your level of sleepiness. And so we know that poor sleep hygiene, those are activities that are inconsistent with good quality sleep or daytime alertness. Those are practices that make it difficult for your body to maintain its entrainment. In other words, to keep the cycles going. So things like during the day being inactive or laying down, not having consistent bedtimes, getting extra sleep on the weekends, or having irregular use of naps. In other words, you can have a nap, but your body needs a certain level of consistency and regularity. Early in the morning, you should get some light exposure because that helps your body understand that it's time to wake up. And once again, any kind of irregular sleep-wake schedule, which I understand can come with sleep work, come with shift work. So that's one of our challenges, can throw your body's circadian rhythm off. Of course, the other trick is we might be using caffeine, nicotine, alcohol, exercising or engaging in eating or social activities late at night, and that gives insufficient time to wind down. My mother, who's in her 80s, actually often talks about the fact that when she has activities in the afternoon, particularly, she can find it very difficult to fall asleep. So what happens is it becomes more and more problematic as you get older to have essentially your body start to wind down. But of course, watching TV, being exposed to light sources, watching the clock, that increases anxiety. Staying in bed when your bed becomes associated with things other than sleep, that can be problematic. And so there's a lot of different sleep hygiene factors that can play into whether you get a good night's sleep or not. And we'll talk more about those as this course progresses, because at some point you're going to be doing a sleep log, and then you're going to be looking at your own sleep hygiene traits and what you might do better. Because here's the trick. We all have times where we're better or worse at these sleep hygiene factors. What else can affect sleep? Well, there's a lot. In subsequent slides, so in just a little while, I'll talk more about drugs, the different drugs that can affect your sleep quality. Pain, people in pain find it difficult to sleep. They get less non-REM deep sleep, and that may also be one of the reasons that elderly or geriatric individuals who experience more muscle and joint pain may find it difficult to get a good night's sleep. Loud or disturbing sounds, lights, smells. Remember, part of our challenge is the thalamus has to help regulate and block all these external stimuli so that you can fall asleep. That can be a challenge if those external stimuli are very powerful or very noticeable. So regular exercise is great so long as you do it far enough in advance of bedtime so that your body has a chance to essentially wind down, because regular exercise typically will increase cortisol levels and work through those cortisol levels. So aerobic exercise is great, especially if your cortisol levels are high because of stress. Aerobic activity can help work through that cortisol. Your cortisol can actually do the physiological job it's designed to do in releasing energy, but we have to do that far in advance of bedtime. Sexual activity seems to be gender specific. Men see sleep benefits, women typically don't report sleep benefits. And then there's nutrition. So larger meals, they can result in longer sleep cycles, but you've got to be careful about how long before bedtime you have that large meal. And then, of course, that means that late night snacking or late dinner typically correlates with poorer sleep, as does skipping meals. We do know that glucose use is very low in sleep because our body is essentially shutting down, particularly in non-REM deep sleep. So I told you I'd come back to drugs. Yes, drugs definitely influence sleep, but they do so on having to take into account some of the factors of what those drugs are doing. So for example, to alter sleep, that drug has to cross the blood-brain barrier. And that's one of the reasons that we're uncertain whether synthetic or taking pills of, say, melatonin or valerian can actually be helpful to your sleep cycle, because it's unclear how much of that drug actually is allowed to cross the blood-brain barrier. Your brain does a pretty good job of trying to keep certain compounds out. Whether that drug is a stimulant or not will influence whether the drug influences sleep, when the drug is taken in the morning versus the evening, and then the trick is how long are you using that drug. In general, your brain wants to maintain homeostasis. So that means as you take a drug, your brain is actually working in opposition to the effects of that drug. So if a drug makes you amped up and excited, well, your brain doesn't want to change that. And so it actually works in opposition and starts working actively to depress that activity. And that results in tolerance. So perhaps you started out taking 1 cup of coffee a day and now are up to 2 or 3. I know I am. And that is due to tolerance. Typically, your brain's getting better and more efficient at counteracting the effects of the drug. You may also then experience withdrawal when you stop using the drug. So withdrawal basically means that because the drug is no longer on board, but your brain had adapted and was working in opposition to the effects of a drug, all that's left now until your brain readapts is the mechanism that your brain was using to counteract the effects of the drug. So if a drug made you sleepy, you were starting to show tolerance to it, well, the drug made you sleepy. That meant your brain was actively working against that drug and was trying to make you more alert. So that means when you take the drug away and you go through withdrawal, your brain is now just making you alert. There's no drug to counteract that effect. And so one of our challenges if we take a drug that influences sleep is that we may become very dependent on that drug, because if we stop using it, we get what's called rebound insomnia, in that our brain keeps us awake. And rebound insomnia can feel very much like a lack of control, can be very distressing for people, and can drive individuals back to using a drug. Caffeine is, of course, we've mentioned it before, is an antagonist to adenosine, and that's how it works. It blocks those receptors. Now, here's an important point. Compared to placebo, caffeine doesn't restore to normal levels after you would have a normal sleep cycle, but it is better than placebo. And placebo is just me giving you a sugar pill saying, hey, this will make you alert. Because we want to be able to make sure that we're controlling for people's faith or belief in the ability of a drug to actually change their behavior or their emotions or their feeling. Now here's the trick. Caffeine consumption before bedtime, it can result in sleep fragmentation, reduced sleep time. It may depend on how sensitive your body is to caffeine. You may know someone who can drink a cup of coffee and go right to sleep. Although here's the trick. You don't know how much sleep fragmentation may be resulting, and they may not be aware of it either. There's a lot of caffeine in even decaffeinated drinks, although a lot's not necessarily that much compared to a brewed coffee. But there is some, and we should be aware that chocolate, cocoa, even coffee, ice cream, things that we might give kids or children have some level of caffeine content. Alcohol is a depressant, and so it increases GABA activity, among other things. It also alters glutamate, serotonin. I used to be an alcohol researcher, and we would call alcohol a dirty drug because it actually influences many different neurotransmitters. But for our purposes here, because alcohol increases GABA and it actually decreases glutamate, it means that it's sedating. And some individuals may try to self-medicate insomnia by drinking alcohol. The trick is, while it does definitely, for some people, hasten sleep onset, it decreases REM sleep and may also result in challenges in that sleep fragmentation issue. So we can get REM rebound in subsequent nights without alcohol because we didn't get enough REM sleep that first night when alcohol is still present. Because here's the trick. Remember, your brain has to play this intricate flip-flop circuit, not just between sleep and waking, but between REM and non-REM sleep. Alcohol disrupts the ability of your brain to pull off that elegant and seamless flip-flop circuit. So once again, we may get fragmentation, sleep fragmentation, in other words, not a great 90 to 100 minute cycle, especially as that alcoholism progresses. What other drugs? Well, tryptophan is the precursor for serotonin. Because serotonin has a calming effect, a lot of individuals will say have a glass of milk before bedtime, but we're uncertain really how much of that tryptophan makes it through the blood-brain barrier and can be converted into serotonin. The same is true of the herbal supplement valerian, which I just mentioned in combination with melatonin supplements. Valerian has been shown as an herbal supplement to increase non-REM onset, as well as the amount of time in non-REM deep sleep, N3 to be specific. The trick is, once again, there may be variation in how much of that valerian crosses the blood-brain barrier, and because it's an herbal supplement, we don't have federal oversight of how much valerian is actually in some of the pills you may take. Lastly, I want to talk about benzodiazepines. Your textbook doesn't cover benzodiazepines, but benzodiazepines are the most commonly prescribed attempt from physicians to overcome insomnia. And it's also a drug family that has the most rebound insomnia associated with withdrawal. So it can be very problematic to start using benzodiazepines. And you may be familiar with benzodiazepines, which is a class of drugs, and it includes things like Valium, Xanax, Ambien. Okay, what are benzodiazepines? Well, they are compounds that bind to GABA receptors, and they don't block GABA from binding to those receptors. They actually keep those receptors open for longer, enhancing the effects of GABA. If you remember, GABA is our inhibitory neurotransmitter, which means benzodiazepines enhance or amplify the calming or inhibitory effects of GABA. So we can use them to treat anxiety, convulsions if you happen to have seizure activity, and we use them to treat insomnia. Now, benzodiazepines are definitely safer than older compounds that we used to use called barbiturates. Barbiturates were used commonly in the 1950s and 60s. Tolerance developed quickly, and the trick is, if we're keeping the brain calm, we may also be calming down respiration centers, the areas of your brain that say breathe, let's keep breathing. And in fact, barbiturates may have caused the overdose deaths of Marilyn Monroe and Judy Garland, because essentially getting to sleep with barbiturates, a sedative effect, It's very close to the same dose that starts to decrease respiration. With benzodiazepines, the therapeutic dose, the calming effect, is further separated from the dose required to alter respiration. And so benzodiazepines are safer than barbiturates. But just to remind you, we definitely show tolerance and then withdrawal symptoms for benzodiazepines. So your brain does adapt. Benzodiazepines work in much the same way on GABA that alcohol does. And that also means that if you're taking a benzodiazepine, never combine it with alcohol. Now, we talked about alcohol making it difficult for your brain to flip-flop between REM and non-REM sleep, and the same thing's going to happen when we take things like barbiturates and opioids. Benzodiazepines, however, don't appear to suppress REM sleep, although some do actually suppress deep sleep. So that means we can have faster onset for sleep, but we're not getting that deep sleep that we may want. Okay, so benzodiazepines are typically prescribed for limited periods of time because of our effects of tolerance and withdrawal for short-term insomnia, for jet lag, for shift work. I know some individuals who were diagnosed with sleep apnea, which is that breathing cessation where your neck muscles, your throat muscles kind of lose tone and you find it difficult to breathe in your sleep. Those individuals are commonly prescribed a machine called a CPAP, continuous airway pressure, where they have to fit something over their nose and wear it during sleep. And that can be difficult to fall asleep to. So they were prescribed benzodiazepines as they were getting used to using their CPAP machine. But once again, limited use. Long-term use of benzodiazepines becomes really problematic. We get that physical dependence. We get rebound insomnia. And insomnia, once again, feels really debilitating. You've got this lack of control, and it typically drives people back to take more benzodiazepines. And part of the thing to remember is that rebound insomnia may not just be because of physical dependence and changes in your brain. It can also be about patient expectations. That placebo effect can be pretty strong. If I think a drug or something was helping me fall asleep, and perhaps you have kids where they need that specific doll or toy to help them fall asleep, that's really important in allowing our brain to basically calm down and fall into sleep. Our own expectations, really important in being able to fall asleep. As you probably have experienced, insomnia can definitely be driven by our own thought processes and focusing on that clock that keeps flashing or showing a time, and maybe you're counting down how many hours of sleep you could get still if you just fell asleep now. So clearly there's a lot going on for insomnia. Once again, we're going to come back to insomnia, but benzodiazepines, those are drugs that are GABA increasing agents. We call those agonists, agonist. Benzodiazepines are GABA agonists. They increase the calming effects of GABA.